Welcome to my new series on integration examples, where I basically run through examples and show you how I do them. Each lesson they'll get progressively harder. Starting on the first lesson, we'll be doing just basics, addition and subtraction, and basic integration techniques. But anyway, these are the three examples in order. Let's get started. So the first example, we have fx equals x. And how do we do this? Well, we use the power rule. So the power rule states that if we have a function x and we wish to find the integral of that, we will get x to the power of n. We will have x to the power of n plus 1 over n plus 1 plus c, which means you add 1 to the power and you divide by the new power, and then you add c, a constant. The reason you add c is because if we were to find the derivative of this, we would get rid of the c and we would end up with that. So if we found the integral of it and we didn't put the c there, and then it wouldn't be correct, because if we derived it, we would get rid of the c, so we wouldn't know if it was there. That's why we put the c there. That's why we don't put a number, because we don't know if there was a number or not. But c says that if there is one, then we've acknowledged that there is one. But that's the power rule, and we're going to use that here. So technically this has a power of 1. X to the power of 1 is x. So the integral we signify with a capital F is x to the power of 1. We add 1 to the power, and then we divide by the new power, and then we add c on the end, which is what this states. And to simplify this, we have x to the power of 2, 1 plus 1 is 2, over 1 plus 1, which is 2, plus c. And that is the integral, or the antiderivative of x. Okay, so I'll do the second example now. Example 2. Example 2, we have fx equals x squared minus 3x. Now, capital F signify the integral. We put the integrand there. I didn't do it in the other question, but I'll do it here and I'll show you why. The other question was too quick. I didn't want to spend too much time on the other question when it was very simple. This will take a little bit of time. So we put the dx on the end and the integrand symbol on the front to signify that we're trying to find the integral of whatever's in the middle, in between these two. Okay, so integration by addition and subtraction, basically they're very similar rules, but we split it up and we have an integrand and a dx for each separate function, because they're not multiplied together, so we can separate them because they've only got, in this case they've got a minus sign, but if it had an addition sign we could do the same thing. So we're going to find the integral of each one separately. So the integral of x to the power of 2, just like before, we add 1 to the power, divide by the new power, add c. And then we subtract the integral. Well, we will 3x, 3 stays the same, or you could, because multiplication by a constant means that you can bring the 3 out the front, so we can bring this 3 out the front, and that way we're only dealing with the integral of x. So x, you add 1 to the power, which should be 1 plus 1, divide by the new power, plus c. Now, that means simplify this, we have x to the power of 3 over 3 plus c. I'll call this C1 and C2 because they may or may not be the same, we don't know. Okay, minus 3. Okay, here's the thing. Because negative 3 is the constant in front of x, multiplication by constants, the rule, means that you bring it out in front of the integral. Because we don't want to touch this bit. We want to touch the x, the unknown. So you bring the negative 3x out the front, find the integral of this, and then multiply it back in once we've found the integral. So that means when we multiply it back in, we're expanding the brackets. So we multiply negative 3 onto the x, which will now be x squared on 2. And then we multiply the negative 3 onto the c2 as well. Some people don't bother with that, but to be thorough, you multiply it in on the x squared over 2 and the c2. Okay? So I'm going to say, I'm going to write over here a rule that says that h equals negative 3c2. Okay, so wherever I have a negative 3c2, I put in a h, a positive h. So over here we have x power of 3 on 3. I'm actually going to add c to this. Add c1. So, because this is technically c1 added on to negative 3c2. So wherever I have a negative 3c2 plus c1, I put a h. Okay? So I'm going to deal with this. This will be take 3x squared on 2 plus h. Because instead of rearranging it and putting the plus c1 at the back and adding it on, because this is all added and all subtracted one another. So instead of adding it on to the back here, I'm just skipping a step and doing it here. I'm making it equal to h, which means I've got all the constants here. And this is what people do at the end. They usually just have a plus c at the end, but because I like to be a bit more thorough and a bit more technical with my integrals or finding the integral, I do this. And this is correct. The other way is people will allow it, but this is the way you want to do it if you want to be exact. Okay? Anyway, so that there is your integral. Now for the third example, we have f(x) equals 5x to the power of 4 minus the square root of x plus 3. Okay. So, hopefully we can agree, or if you know this, that this is the exact same. Square root of x is the same as x to the power of 1 over 2. Okay? Keep that in mind. Now, I only really showed you this step to be 100% technical and show you exactly how it's done. I'm not going to do it in this example because this takes time, but I wanted to show you how it's done exactly. This process will be quicker and technically right. If people want you to do it exact, that's the other way. If they want you to just find the integral, do it this way. If time is a constraint. Anyway, so we find the derivative of 5x to the power of 4. So we have the 5. Now we find the derivative of x to the power of 4. We add 1 to the power, divide by the new power. Okay? This 5 is multiplied on, by the way. And then we subtract the integral of x over x1 over 2. So we have x, we add 1 to the power, so that's half plus 1 over half plus 1. Okay? And then we add 3. Now, this is a rule of when you've just got a constant on its own. And it basically means you have an x to the power of 0, because x to the power of 0 is 1, and 3 multiplied by 1 is 3. So you could say that there's an invisible multiple of 1 there. Okay? So x to the power of 0 is 1, so we're going to include that. This is still 3, by the way. 3 multiplied by x to the power of 0 is still 3. But for this purpose and the rule, which states that, you add 1 to the power and divide by the new power, which is 0 plus 1, plus c. Remember to put the capital F out the front. I should have done that before. Anyway, so you've got the integral. We'll simplify this. This is 5 multiplied by x to the power of 5 on 5. So we get rid of the 5 divided by 5. Minus x to the power of a half plus 1 is x to the power of 3 on 2 over 3 on 2 plus x to the 3 multiplied by x to the power of 0 plus 1 is 3x to the power of 1 over 0 plus 1 is 1 plus c. See, in this other example, I added a c on every, after I did the integral of every one, and that is to be exact. But the quick way that people tend to deal with, you just add a c on the end. You just add the c on the end, because you could say that c equals the addition of all the constants that you get from the integral of each one. Okay? Just like how I did with the h. The h is equal to all the constants added together. Okay, anyway, so we'll simplify this. This just leaves x to the power of 5 minus, well, we have a fraction within a fraction. If it's on the bottom, what we're going to do is we're going to flip it and multiply it back on. That's how it works. So we're going to have 2 over 3 multiplied by x 3 on to the power of 3 on 2. See what we did there? We have 3 over 2, but to get it to not have it in that state, we have to flip it. We have to bring it out, flip it, and multiply it back in, which is what we've done. We've brought it out, we flipped it, and then we're multiplying it back in. Plus 3x, because 3x to x to the power of 1 is just x, and over 1, it's the same thing. So this equals that, and plus c. So what we'll have at the end is x to the power of 5 minus 2x to the power of 3 on 2 over 3 plus 3x plus c, and that is the integral. Okay, well, thank you for watching. I hope you learnt something, and have a good day.